but I want to welcome everyone to the show tonight. I'm going to be talking about the scrolling wrench, and then Dennis is going to talk a little bit about scrolling tongs. These are all tools you would make for your level 2 skills. So I want to welcome you. Some of you may have attended my hand tool talk, and that scrolling wrench is in there. So this might seem a little familiar to you. And as you know, I use Mark's photos and his videos. So he gets a mention here along with Dennis and I as to who's presenting tonight as part of the education team. As I already mentioned, I'm going to go over the scrolling wrench. Dennis is going to go over the scrolling tongs. And this is part of a greater effort headed by Beth Holmberg to work on or have everybody have presentations for level 2 skills. So the scrolling wrench there's 2 of them in this picture, and we use those for any kind of bending. So they're really not limited to scrolling, but anytime you want to do some bending, and there's some common sizes and the size, but when I say size, I mean this gap right here. And you want it so that it fits the task at hand. There's popular or most used sizes for me are 1/2 inch, 3/4, and then 1 1.25 inches, which is if you're working with some pretty big stock, or it's going to be whatever you need for your particular project. They're always about 1 inch tall. So the scrolling wrench that I'm going to show you starts with 3/8 by 1 inch flat bar, and that should get you to all those sizes. I'm going to be using mild steel. I have several that I've made from mild steel, and I case harden them, and I find that that works just fine. There's really no need to get into any higher carbon steels. I work everything hot, so there's not a lot of torque being put on these little guys. If you are working with something bigger, or you wanted to maybe work stuff cold, maybe think about kind of a spring steel for this kind of action, but mild steel, case hardened, is holding up very, very well for me. There's 2 shapes you can put on the end. Actually, there's probably more than 2 shapes, but the 2 shapes I'm bringing up here is a cone shape, which will help you get into tighter spots. And then there's the one I'm going to show you, which is the chisel point, which is what you would use for scrolling. Regardless of the shape, you always want to make sure these inside edges are relieved, because they're going to be directly covering or touching your material. You do not want them galling your work. The cones would probably be good for anything with a tight spot like leaf work, and that round shape already is going to prevent any galling. Now, our goal is to make these tines or progress through this tool in such a way that they're lined up at the end, and you have just enough to file evenly. The way I'm gonna make this tip can be vulnerable to some mushrooming, so having a little extra there to file off later is perfectly acceptable. So our first step is we're going to use a 3/8 by 1 inch bar, and we're going to lay off 1 inch. Now, the question is, I'm sure burning on everyone's mind, is how do I know it's 1 inch? Well, there's some math I'm going to talk you through a little while later. I didn't want to hit you with the math right out the gate. I thought maybe I'd lose some of you. So hold on to your hats for that. So we're going to lay on 1 inch, and that'll get us a 1/4 inch gap when we're done. Set that down to a 1/2 inch square. Since this is a 3/8 bar on the parent stock, it's going to end up a little wider when you get to that 1/2 inch. Make sure you have a nice even square on all 4 edges. When you're doing something like that and making it square, it's a good idea to chamfer all of your edges, and that'll reveal rather quickly any different lumps and bumps that you might have. Next, you're going to lay off you're going to bring your piece all the way out to the other side and lay off a very hardy 1 inch. You could even make a case for 1.125 inches, but a strong inch, keeping in mind that if you're doing this over the rounded corners, you want to measure from this outside edge, not the top of your anvil. And I would recommend using rounded edges so you don't end up with a crack later, because a sharp edge could lead to a cold shut. Once you've laid off that strong 1 inch, you can start necking down your handle. The handle is also going to be set down to that 1/2 inch square, and keep that even as you go. There's no taper here. The handle is going to be straight. That will help you later, because we're going to put this down in that post vise, and you need the room here for your fuller. So let's watch a little video about that, just getting started to that point. So an even 1/2 inch all the way around, and then lay off that pillow, chamfering the edges as you work. Anytime you're drawing out a long swath of material, using the bic and the rounded size of your hammer will move that along a little faster, because you'll be squishing and stretching faster than you can on the flat of the anvil. We're now ready to take our pillow, our isolated material, and turn that into the tine that's closest to the handle. This is accomplished by fullering and squishing out this material, and it's a good idea to do that in a post vise with a backing plate. What the backing plate does is keeps you from galling this material on the far side of the post vise as you move along. And the backing plate is literally just a piece of flat bar welded to some angle iron, and then here's some angle iron on the other side with rounded edges. The piece is going to be upside down, or that initial part that you laid off, into the post vise. You're then going to take your fuller and start to move this material out. And it's going to be important that that fuller be as straight up and down as possible. If your fuller comes in at this angle, you're just going to end up encroaching onto the handle, and you won't actually be moving this material out. So fuller, straight up and down, and then take your cross peen or even your hammer and start to smooth out the lumps and bumps that you'll create as you move along. Now, anytime you're hitting from the top, you're going to get a growth in thickness. That needs to be corrected as you go, or you'll end up with something a little unwieldy that is going to be difficult to get back into shape. Because remember, we're trying to get this tine out this way. So keeping that thickness in check as you go becomes very important, or you'll just end up thinning this and it'll get way too wide for our purpose. When you correct for growth, that's highly likely, actually it's not, it's going to happen, that this angle is no longer 90 degrees. It's going to shut down less than 90 degrees, which means when you put it back in the post vise along the rounded edge of your angle iron, you're going to have a little gap here. When you push down on that, that gap is going to create like a little fissure. It's going to close around itself, and that leads to a cold shunt, which after you've worked so hard on this tine is going to make that tine fall off and you'll be very unhappy. So make sure that you're always working with a 90-degree angle for that. That means you'll need to put your wrench in the post vise and maybe using a set tool, relieve that back to 90 degrees by the hammers coming from this direction. So taking the fuller and the cross peen, continue to work that out till you have a strong 1/2 inch here down to a chisel point. So it's going to be 3/8 of an inch wide, but a long taper on the one side. So notice how straight up and down that fuller is as you are working. So you start close to the handle, move towards the edge, and then the hand hammer to continue to draw that down. You're going to have to go through these steps several times till you have a tine that is 1 inch long. And you can see how correcting for growth, suddenly now you no longer have a 90-degree angle. So taking a set tool, straighten that back out, and now you can work it again with no gap here. We now have one tine formed. It should be 1 inch long, and we have all of this material here that is allocated to the other tine. We need to cut off any excess with your hot cut chisel. And what that means is we need to know what is our excess, because what we don't want is too little material. We could always file it down, but if we start out with too little material, we will have a tine that's too short. So that means we have to do a little bit of math, and I'm going to give you the answers here, and we'll get into this a little more later. But I basically have my height, which is my 1 inch, and it's going to be a taper. So if I think about how much material I needed to make a tapered tine, I can cut that. I can cut the parent stock in half, because you can almost see on the other side of the triangle here how that same amount of material would fit in there again. So I'm going to take half the height for my tine. I'm going to put a bend in place, and then what's left is the width of my gap. A rule of thumb for the bend is make it the same as your material is wide or thick. That means I'm going to take half of 1, because the height is 1 inches. I'm going to take a 1/2 inch for the bend, and I want my gap to be 3/4. I add all these together, and I know that I want from here to here to be 1 3/4 of an inch. Once I have that amount properly allocated, I'm going to remove some of the sides. I know I want a taper, which means when I hit this to make my taper, the material is going to grow side to side. If I get ahead of that, if I outsmart it and remove some of that impending growth ahead of time, when I make my taper, it'll end up spread to the right amount. The position you don't want to be in is having your taper in place and now having to push that material back in because it will have gotten thin. And if you've ever tried to squish in thin material, you know that it just bends and gets all wonky. So the way to get ahead of that, remove some of the material ahead of time. Then when you make your taper, it grows to the width that you want. But do keep it in check as you go before it gets too thin. If you'll notice also, we want to make the taper on this back side of this handle. And that means this tine has to be down. This hammer edge has to go somewhere. And that somewhere could be your hardy hole. Just be very careful you're not digging that up. Or it could be over a block bottom swedge, which is a very handy way to give yourself an edge with a shorter distance here than your anvil might have. Once you have your taper in place, which anytime you're making a point, get to the point, make the point first. Now we can taper that back so that it's 1 inch in length. When you have your 1 inch in length, this is your best time to relieve these edges. You can do it later, you just won't be as happy about it. So taking a file now, or even chamfering these edges like you did at the beginning, taking these and filing those a little bit round is really going to help you later to prevent your work from galling from the use of these scrolling wrenches. So measuring exactly what we want and removing the excess material. Checking that growth and width before you get started and keeping it in check as you go along allows you to make that taper that 1/2 inch width, or maybe even a little less at this point. Relieve all the edges on the inside. And I don't see any questions yet, but I do see some comments in the chat that the Dennis Tong held fuller works really great. That's how I made mine, was using those fullering tools. And yes, those blocks do rock. All right, we're now ready to bend our tine. And in order to do that, we need to get this part hot. That's going to be hard to do without getting the tip hot, so you'll need to quench it. If you have carefully placed your taper to the 1 inch, that's how much you need to quench, leaving the gap and the corner material red hot to bend. So with this hot this quenched, go ahead and start your bend. Do it over the horn, and you want to concentrate it here, but don't take that closed yet. You're going to save that for the end when you have your material and after you've upset this back onto itself. You're going to get some, when you bend this, even if you've done a good job of isolating your heat, you're going to get some bend traveling into the gap, and you might even get some into your handle. That's okay. Just leave it in check and keep this bend open more than 90 degrees. We're not going to use an upsetting motion to upset this so that you end up with a nice full corner. Because really that's what we're doing. We're trying to get this extra material set down in here so that you have a very strong or robust tine for your scrolling wrench. The motion for that, or what you want to do, is reheat this whole jaw and quench this front tine. This one might end up a little quenched too, but you really want to focus on this. You can then drive the tine down towards the anvil with your hammer stroke aimed towards your knee. If you bring that straight down, you're just going to roll this out and you'll end up rebending it. This is also where you'll see a little mushrooming, so you don't want to over thin that tip. And remember, we're going to file that later anyway, but you will get a little mushrooming even if you've cooled that well. So with your two tines in place, and you knew ahead of time what the width of this gap was, you can now put that back into your backing plate that you welded onto the angle iron, and you can set this back using the material that's the right width for your gap. Notice that the edges are relieved so that you don't gall your tool. So first blow takes this straight back. See how this is a little off the backer plate here? First blow straight on your material with your hammer that gets that flat up against that backing plate, and then gently tap this down, but don't overdo it. So let's watch all that happen on the video. Notice the hammer stroke is coming this way towards the smith's knees. And notice the handle did get a little wonky. That's okay. You can always fix that later. So straight flat against the backer plate. Correct for any growth in width, and you have the working bits of the scrolling wrench ready to go. Now's a good time to go ahead and file that off, especially if it's still hot. It's almost always easier to hot file that. So I don't see any questions in the chat. Hopefully everybody is doing okay. And I'll keep going. But don't hesitate to put questions in the chat if you have any. Okay, so I showed you this slide early on, and I warned you there was going to be some math. I also sent you a handout with the next couple of slides that have all the math on them. So keeping in mind our goal of how much we want to make sure we have enough material to make this tine with the right amount of gap, material for the bend, and a 1-inch taper. We need to ensure that you don't run short. The worst would be to not have enough material. So how did I know to lay off the 1-inch? And it was with a fairly simple concept regarding volumes. You could experiment or just use the measurements I give you. But if you're anything like me, you don't like being told what to do. You want to know for yourself. So knowing the math and doing some simple volume calculations will allow you to take your blacksmithing to the next level and maybe even impress your friends with what you know. The volume formula is the height times the width times the length of what you're working with. If you took that amount of material that I initially laid off, that 1-inch, and the finished tine with the bend and the gap, and you dunked them both in a vitrol with water, they would displace the same amount of water, giving you the volume. So that would be one way to go about this, but I don't know about fancy little glass beakers in the forging area. So instead, we're going to use math. And you're doing a whole bunch of stuff to this metal, but the volume never changes. That means the height, width, length to end is the same as what you started with. You just moved it around a little. You may lose a couple percentage of that to scale, but not enough to worry us. We're blacksmiths, not machinists. So if I plug my formula in, if I plug what I know into my formula, we can get to the point where we have one open variable and do some simple algebra from there. So we know our height is 3/8. We know our width is 1/2 inch, and we don't know our length, and that'd be our goal length. And it's 100% dependent on what we want our gap to be. We're starting with material that is 3/8 inch wide by 1 inch tall. I now have 4 variables of my 6 accounted for. So let's talk about our goal first, because if you don't know where you're going, you're going to get there, which is nowhere. So we want to know where we're going. And we know we want this amount that I reviewed a little earlier. It's going to be half the height, which is going to be 1/2 inch. The bend, which if this is 1/2 inch, the bend is approximately 1/2 inch. And then we have the width of our gap. And that's the one that's determined by you. So we've got our 1/2 inch times our height, plus our bend, plus our width for our gap gives us our goal length. And if we just plug all our numbers in, we know that we want 1.5 inches for a gap of 1/2 inch. We can now plug that number in to the goal side, and we can solve this for the length to start, which is how much are you going to lay on to do your initial forging. So before we do the math, let's think about this for a minute. If we know that this volume is the same as this volume, and I know that I want this to grow to 1.5 inches, and it's going to be 1/2 inch thick, which is half of this 1 inch we're starting with, I really want to double this. So if I take 1.5 inches by a half, since I'm cutting this in half, that's 3/4 of an inch. So that gives us, like, if you stop and think about, okay, I'm doing this formula, I'm doing this math, does it still make sense? Right now, what would make sense is if we got to 3/4 of an inch to start, to stretch this, make it half by half, to stretch this out. So let's do that math. And here's where, you know, fractions are fun, but I don't know that they're your friend. So we're just going to complete this for L. And I did all the hard work, and I put all these, multiplied all these together, divided both sides by these two together, and you get this lovely little formula. And lo and behold, that is 3/4 of an inch. So to give you all a leg up, I did all the math for you. So if I want a 1/2 inch gap size, I know that I need 1.5 inches for that second tine. I need 7/8 of an inch, which is me adding a little bit of material because of that rounded edge. So lay off 1 inch to get to 1 3/4 of an inch for your 3/4 gap. And that was the one I showed you to start. And lay off 1 1/4 to get 2 1/4 inches for a 1 1/4 inch gap. I don't see any questions in the chat, so hopefully I haven't lost anybody. And I did give you these slides in on a Word document. We're now ready to finish the handle, and this is a tool that you're going to be holding in your hands and maneuvering back and forth, maybe from the top, maybe from the bottom. And that means you don't really want it very long. I would say 12 inches is the max. You don't want it too short either, because you are going to be working with hot metal, so you don't want your hand up against that. So, maybe 10 inches at the shortest. That would be up to you, but we'll start with this about 12 inches long. And you don't have to do any volume calculations for that. You can just bring that out to where you want. And keep it to that 1/2 inch by 3/8, which I know I told you to make a 1/2 inch square to start. That's so you had to have a little cushion, because I find that as I'm forging these tines, they'll get thinner and thinner. And if I start too thin, they end up much less than my parent stock or my 3/8 by 1/2 inch. And then be sure to chamfer all of your edges, because you are going to hold it in your hand and you want it to be comfortable. I'm going to talk through making a happy little eye like this for 2 reasons. One is shop space is at a premium, or at least it is for me. So having a tool that can hang on the wall is very helpful. And it lets me do some more math. So, and I do like math. Okay, I'm getting distracted by the chat. Depends on the gap size material you're going to bend, I think. Handle size, stock length. Okay, so Mike, I'm not sure if that was a question or just an observation. But
I'm just saying that if you're building a tool to twist 1 inch square stock, you're probably going to start with something a little bit heavier than 3/8 by 1. And you're probably going to make the handle more than 12 inches long.
Absolutely.
That's all I was saying.
And that is an excellent point. You are 100% correct. Thank you, Mike. And I'm glad you're saving the heckling for Dennis. There we go. So All right, we're going to do a little math. And this math, I'm giving you the answer ahead of time. So everybody can stick with me. You don't have to worry about coming up with the answer on your own. It's not a test. But if I want to know how long this tine or this rounded piece of steel needs to be to get a particular gap size, I need to plug it into a formula where I can get the circumference. And the formula for a circumference is pi times diameter. Now, I already said that we are blacksmiths, not machinists. So when I think about pi, we all know that it's that formula, 0.14, blah, blah, blah. I'm only worried about the 3. I know that I want that to be 3. And I'm not going to worry about the 0.14, etc. And that's going to get us close enough to where we want to be. The diameter is this little blue line here. And the blue line, if you'll notice, cuts this bar in half. And that's because anytime you make something round or you bend it, the metal stretches on the outside. It's got longer to travel. So this is a longer length. And the inside was compressed. This is a shorter length. The only bit of this that stays the same as my initial measurement is the neutral axis or the center. That means when I'm thinking about how long this needs to be, that has to be considered. And all I have to do is extend my diameter to the center. Fortunately for us, we're going to make this 3/16 inch wide. So 2 of half of 3/16 is 3/16. So it's really just the material again, plus the interior dimension that you desire, which in this case, I'm calling out 5/8. Add those together, that gives you your diameter, and take that times 3, and voila, you know how long this needs to be to make this eye happen. So now we're just going to make this eye by laying on 5/8 of an inch, and I got there with volume calculations, and you now have the tools to do that, but I'm not going to take us through that because I think I already did enough math for one presentation. So lay on 5/8 of an inch, and quite frankly, if you did a little extra here, you'd be fine. You just don't want to end up with too little material. So 5/8, and you're going to draw that out to a taper that is 3/16 of an inch thick. So I would make the square just a little fatter. Actually, let me back up. We're going to take that down to 3/16 of an inch thick and flatten all the swelling. Then you want to take, so I have one shoulder here. Then we want to take the other side and make a shoulder that matches. So you'll have 2 matching shoulders on this square bar. Then you can draw this out to 3/16 inch thick and then round it. Anytime you want to make something round, you're going to go from square to octagon to round. Same principle applies here. Try to keep this as even as possible unless you want a little taper. I suppose you could put one in. And then we want to cut that. You should have a little more than that 2 7/16 of material. Cut off any excess. And if you're feeling fancy, you can cut this off at a little angle. This little slant will allow it to fit nicely into the shoulder when you're done. So lay off as much of the eye material as the material is thick, because we want this to be smooth and it needs to have a place to go. So stick that out this dimension, which is our 3/16, and then go ahead and bend that down, smoothing this angle so that it's nice and flat. And that's what's going to come all the way around. And this little slant will fit nicely into this bend you're creating. Bend that to about 120 degrees and make sure you've dressed this nicely. You now can start your bend, and you want to round it to the correct diameter. You can do that by sight, or maybe you can have a 3/8 round handy that you can measure up to, but it's usually best to start rounding one end, round the other end, and then you can have them meet in the middle. And then just work it around your bend. Now, anytime you're bending, you shouldn't be hearing the anvil ring. That's forging. If the hammer hits this over something hard, you're forging. We're bending. So make sure, and you can see this hammer is very nicely poised to hit over air. If you hit over air, you're bending. So let's watch all that happen in a video. We're going to cut off the remainder of material that we don't want for our handle end. And then we're going to forge that down to the 1/2 by 3/8 in line with the remainder of the handle that we already created earlier. Keep everything nice and straight. And here we're gonna lay on that 5/8 of an inch and just draw that out till we have the 3/16 inch long round eye. We know we want 2 7/16 of an inch, so we're going to mark that out and cut off any excess, which is a good position to be in at this point. You want a little extra, not too little. Notice bending, so hitting over air, that's not forging. Hitting over air, over air. And once you get everything bent on those two edges, continue to hit over air until you've created your eye. Notice that every time when the hammer's hitting this, it's positioned in such a way that there's a gap there, and that allows the material to bend. Okay, we're now ready to case harden, and case hardening is just like adding a hard outer shell. Like think about like a M&M candy. It's gonna last longer. It's gonna do a little more. It is still soft in the middle, but it is going to buy you a little time with your tool. And it's a good idea to read the directions before you do this, or maybe even review it with your local instructor. But in a nutshell, you're going to heat it to the transformation temperature, which is austenitic. And we need that to get to martensite, which makes the tool hard. So with your tool in that austenitic temperature, which means 1650, it's going to be a cherry red color. It will have lost its magnetic properties at that time. You apply the carbon. When you quench this, that turns to gas, and that carbon penetrates your metal, giving you that hard outer shell. It should be wet when you're quenching, and you should hear a loud pop. If you don't, go ahead and do it again. Sometimes I'll heat it, apply, heat, apply more than once, and then quench, and then do it all over again. As long as when I'm done, I can test it with a file so that the file should be skating off it. That'll give you enough hardening on the outside to have a tool that lasts a little longer. Okay, that's all I had. I wanted to get through. So why don't everybody let yourselves back in the room? I wanted to get through that in time to give Dennis a good hour and 10 minutes or so for his section. And any questions on any of that?
Yeah, I have a question on cherry red. So, I was taught case hardening with caseonite, which of course is no longer existent. So I bought some cherry red, and I am finding that it leaves me with really kind of nasty surfaces that are not very flat. And am I the only one getting that? Or is this something that we're seeing? And I assume it's the flux that's in there. But yeah, I find it. Blech.
Yeah, I brush mine off right away, or even reheat it just a little bit to do that. I have the Brownells compound. I haven't tried the cherry red myself, and I've had good luck with that. It doesn't leave any kind of goo on there.
Yeah, this is more like it changes the texture of the actual metal. So really? After I've cleaned it off, I now have, instead of having that nice flat brush surface that I had before I put this stuff on, I now have a
Yeah, the Brownells doesn't do that to me at all, and I've never tried that cherry red.
Where are you getting it?
The Brownells. I ordered it online a while ago.
Okay. From Brownells.
Perfect.
Yeah.
Brownells.
It's a gunsmithing catalog.
Okay.
I just put it in the Google and gave me the answer.
Thank you.
I have something I can add.
Yeah, if anybody else has anything about cherry red, great.
Oh, I don't have anything about cherry red.
Oh, then add anything you want.
When I was making a bunch of bending forks for Weaverville, I just was running kind of a production line of or turning it into a production line. And if you can see, when you're on Mark's videos, when you're bending over the horn to get your gap, I just made a little fixture that this fits in the vise, and this I have a little 1 inch on here, so this would fit a 1 inch one, and I would just put it over there, and I just move it or forge it right over my little mandrel, and there I had my, because I was doing gobs of them. So I made a little 1/2 inch one, a little 3/4 one. So if you're doing a bunch, something like this might come in handy.
So with that said, I'm going to share Dennis's slides, and
I wanted to start out, I have my notes here, so I'll be looking over. My name is Dennis Dusek. Some of you know who I am. Some call me Double D, Sheriff, Hobbit, Baggins, Luke Duke, you name it. I have multiple names of, depends on the person. So I started in education, CBA education, probably in 2010. I've done 2 tours of being the vice president. I've chaired 2 conferences and been part of probably 10 or more conferences. And my God, many events. I've been a demonstrator. And my God, what else? Yeah, everybody has a different way of doing stuff. And basically you can just take what you like from other, take from other artists and just make something your own. So today we're going to talk about scrolling tongs. So Toby Hickman was a big part of many of our lives, and he said, if you can't hold it, you can't hit it. And it's so true. I mean, how many of us have tried using a pair of tongs that don't fit, and you're trying to hold it and you're struggling and it falls on the floor, your heat's gone, it's awful. So what he says is true. So let's go right into material. Today what we're going to be using is some 3/8 by 1. Asprey likes to use like 3/8 by 3/4. Fine, no big deal. Mild versus a higher carbon steel. Mild steel is just fine for a lot of stuff. If some stuff I'll make out of 4130 or 4140 or even 5160 or some of my friends have made tongs out of titanium, and so just depends on what you're doing. But mild steel it's so good to practice with. Save the good material for tooling down the road. Mike has his hand raised. Go ahead, Mike. Just unmute yourself.
I just wanted to add one thing, Dennis,
Yeah.
and it's goes along with what Toby said, and I'm sure Toby was actually saying it in the way I'm thinking about it. You can't work on something if you can't hold on to it, and if you can't hold on to it securely when you're using a power hammer, it's probably going to rip your guts out.
That's absolutely right. He had some pretty horrific stories that he was telling us about other guys. But yes, it's very true. So yeah, a lot of farriers like titanium. I see that question coming through, your comment. It's real light. I have a pair. Titanium is funky to work with, but anyway, that's not quite part of today's lesson, but I put it in there. Why to use high carbon or higher carbon stuff? Well, you can make it thinner, and it can still maintain the strength. If you make it thinner, it can be lighter. So that's something to think about. But most of the time, your mild steel is just perfect. So I think I know what I was going to ask. I have heard that some people will make their tongs out of mild steel and then they super quench them. I have never done this. I've only heard people doing it, but I thought I would throw it into so let's go to the next slide. All right. So when you get to the power hammer, Okay, so Beth has super quench scrolling wrenches. Okay. And did it come out fine?
Yeah, it works great. I mean, it gives you hardness without losing toughness. It makes them more resistant to bending. It's great for turning thin stuff into something that acts more like a spring, even though you're not adding carbon. I love Super Quench. It's $12 to make a batch, but it lasts forever.
Awesome.
It doesn't do anything wrong, you know. As long as you're using it on mild steel, nothing bad can happen.
Okay. Okay.
Yep.
Like I said, I've never made it, so that's awesome to hear. So, basically I need to try it. So, awesome, Beth. Thank you. To the power hammer. All right. Ask your education folks to set up a power hammer workshop, especially if you haven't worked underneath a hammer. You will learn a lot. You learn a lot about hit turns and forging on a flat dies and combo dies and top tools. I mean, there's so much cool stuff you can do on hammers. But you have to, it's dangerous. It has, you have to treat it, it's like a car, it's like a machine, it's like, so it can hurt you. Anyway, the class, a workshop, I've done a couple with Toby, and boy, I came out of there. Every class I've taken from him was just phenomenal. You get your confidence grows, just leaps and bounds. And I remember one time I was working on a little piece and I was kind of timid, and Toby would get up right behind me. He was a big old bear, and get up right behind me, and he would push that pedal down all the way to the ground, and you're just trying to keep it together. And so he really, really taught me or a lot of people how to forge on the hammer. So, but a lot of safety. So let's go to the next slide, and we're going to talk about power hammer versus hand hammer. I don't know, that question from Bo, maybe Beth could answer it. All right, okay. Things to keep in mind when you do your calculations, just like Victoria did. You know what is really cool? Get yourself some clay, forge it out with clay, and you will. There's your volume right there. How much do you need? So clay is your friend. Oh, go ahead, Beth.
I'm just going to type in the formula here for everybody.
Oh, okay.
Yeah.
So please practice your material calculations on your volumes, because doing the stuff on these little tools is perfect practice for when you actually get a bigger job and you really need to know the volume, because you might be handed a round, 2-inch round bar, and you have to calculate the volume, and that you need to make this X how long. So practice is perfect. Go to Google. Nothing wrong with that. So nice low heats. Go back over and you can crisp up your edges. I don't like sharp corners on just about anything. Of course, cracks will form. And my God, it is so easy to overforge either with the power hammer or with the hand hammer. So let's move to the next one. All right. So I injured myself, and my biceps tendon came off, and they had to surgically go in and put it back together. So I was down. I'm still kind of down. So I'm not one to sit around, and so I made a fixture. The one you have on your screen. I made this fixture, and I made it so it can fit. Here's my bottom of my power hammer die. Can everybody see that?
Yeah, we can see it.
Okay. So I made this little saddle, fits right over the die, and I can fit multiple tools in here. And your imagination will keep you up at night on all of that stuff.
Man, look at the size of that die.
Ah, well. Can you get me back to the slide? Oh, okay. So this is how I made, this was our first operation, second operation, third operation. And unfortunately, I do not have a pair of the scrolling ones, so we're going to use this for the moment. This would be our first operation, second operation, and third operation.
We couldn't really see
Oh, okay.
exactly what you when you were holding a piece of half a tong, and we couldn't really see what you were saying was what, bud.
Okay. Well, there's actually a video that's actually better.
Perfect.
So let me go back to my notes here. So anyway, I was injured, so I wanted to make Weaverville a bunch of tongs, and so I made up this fixture and just started. I could, basically do it left-handed, pretty much, everything on the hammer. So that was kind of nice to get something done when you're laid up. So, all right, let's go to the next slide. Making tongs. Okay. Let's get into basically what I want to show is it's really the same thing either on the hammer or on the anvil. You can see you get the same outcome either way. So, and sometimes I use both. I'll do stuff with the hammer and then go back, chew stuff up. But how I started this was, you got to have Asprey's book. I have it over here, but it's fantastic. It has everything you need to know about starting these things up. So that's basically how I made this fixture. Was I basically went into Asprey's books and just turned everything around and tried it out. So, all right, let's go to the next slide. Okay, setting down the jaw. you can see I measured off 1 1/8 inch, and you can see when it was forged down. All right, let's go to the next slide. And then we're basically setting the boss. And again, it's the same thing, this half face blow, either on the anvil or on this little fixture, right where Victoria's pointing. And that just pushes, this creates the boss right here. It pushes that tong or that bit down. So let's go to the next slide. Okay, I like bigger bosses. Asprey likes a little bit more compact one, but it gives me room to, you know, if I, for my rivet. It gives me room if I want to, you know, make this a little wider. Or anyway, I can move my rivet up or down. So that's why I like a little bit bigger boss. I also like to have the boss super smooth. I like, I'll even go back and I'll forge it as nice as I can and go back, hit it with a file. I'll even do that. So we're ready for the next one. Oh, wait a second. Yeah, we went over smooth action. And now, okay, let's go back to over forging. It's so easy. We've all done it. We're all going to do it. Try and keep that really clean when you're, I like to brush this off so you don't get a bunch of scale under here and you get divots or just crap in there. So clean it off, forge it again. And you can use a set tool or a flatter. Again, I like to kind of, I'll even hit it with a file because I like mine. I like really nice, slick feeling tongs. So that's one big thing I like. So in this slide, you can see you're going to need a gap. You're going to need some room between the boss and your bit. So give it a little bit of room. You can see where Asprey is showing in his slide here that, and just to give it some room for when your matching pair come up and they don't fit. So, all right. Next one. All right, the back of the boss, where the reins will start, is in my third right here. I like it's so easy to over forge this and make this super thin right here. Leave it fat. You leave it voluptuous and chunky, you know. There's a lot of strain right here. So that'll help you immensely if you keep this and this where they're not over forged. So let's go into, is this the video? Yeah.
Yeah, you ready?
Yep, I'm ready. Okay, I have my 1 1/8" marked off. You can see my little center punch mark there. And I'm moving over 90 degrees, forging the boss, kind of pushing the bits down, the material for the bit. And now this will be the back of the boss. So you see how I started it there? And so I got another heat, and I'm going to go back and repeat. So this is great if you guys need a bunch of tongs. Your group can make a fixture like this, and with a big team, you can really tool up your workshops. So, and that's, I mean, perfect for a basic blank. You can do a lot with this. So, super easy. Let's move. I see there's a chat. Let me check. Okay. Okay, so now I really like these blocks. I call them Asprey blocks. They are the cat's meow. I just love, because most anvils are too wide for doing small tapers like this. You want to take your bit and start forging it down into a nice taper. Of course, taper square, keep everything uniform. When you got that, go back and start forging the edges, and you'll make an octagon, and then you can go to a nice round. Then after that, you can hit it with your file or hit it with your belt sander or whatever you got. It's nice to have a smooth, especially the insides, instead of all lumpy or anything. You know, you don't want to crease your parts, but now's the time to do it, is clean those suckers up. So, all right, next one. All right, so that was by hand, and you can see I'm using a top tool and basically doing the same thing. I am just drawing out the little bit with this round back flatter. I was able to do that with my right arm. I got through one, and then I had to quit when Victoria was over. So, let's, oh, okay, good. Here's a little video of, so these top tools are really quite easy to make. This one just has a welded handle on it. It's a piece of, I don't know, 4140 and just a mild steel handle. I've made that one. And I've made some that are just full length of 4140 or whatever. Is the round back fire, so it can hit at multiple angles. It can hit at a taper. You can see that the top of that top tool is round, and the top die of the power hammer will hit it just fine. And I'll show you when we stop. I'll show you another one. I brought two of them up. So this is, I mean, for getting a lot of work done, a little power hammer is worth its weight in gold. So. Something I want to mention that okay, well, I'll mention it in a bit. You can see Victoria here had to take over, and she's finishing up, rounding up the bit. But on the when I was using the power hammer with the round back flatter, you can see that I left this area kind of alone. I basically worked on the sides and the back. So, but look at how nice that is. It's quite nice. All right, let me go back to that chat and finish. I've been taught that any handheld tool underneath the power hammer should be rounded for, okay, yeah, that makes perfect sense. So there is a nice blank for our scrolling tong. So let's move to the next one. All right. So let's talk about reins. I mean, tongs are very personal, and reins should fit you. That's, so I brought a bunch up, and there's something I should start before going into this is, you know, if you're doing this on the anvil, you might want to forge weld your reins on. If I'm on the power hammer, I just draw them out. So that's one thing. But see, these are kind of big and clunky. They're store-bought from somewhere, Germany. These were a gift from anyway, this particular person likes the little balls at the end, you know, basically a tapered square, rectangle. This is a set of John McClellan tongs, where they're basically kind of turns it to where it's wide, where your hand goes. You guys can see that. Really, really old pair of tongs, very similar to what John McClellan, I was just showing you on John McClellan's. Here's a pair of, actually, Toby Hickman made these tongs, and that's, I like his reins where they're a tapered rectangle. That's what kind of what I tend to follow. Here's here's a set of mine, basically very similar to Toby's on the reins. So, so Tong, I mean, well, actually, tongs are very personal, and you should go and handle other people's tongs and, you know, find out what you like about them and add them to, you know, what you make. So, or what you like. So this is a pair of insert tongs that, again, they kind of come up a little fatter here. So, all right, let's move on to, I like longer tongs, especially if you're working out of a propane forge. Because a lot of propane forges, they got that big blast, and you open the door and trying to get your little part out, and you're just singeing your arm hair and stuff. So, but on the scrolling tongs, I don't like to make them too long. I mean, that's plenty long, especially for, you know, these level 2 and 3 projects. You don't need some ginormous 8-foot pair of scrolling tongs. So some people like them round, some people like them like tapered, triangle. We went over drawing out and forge welding the reins on. So just make them how you want them. So they need to fit you. That's the main thing. I will add, I do like to put my tongs in alignment. Like this one comes where they're just kind of bent and they eventually come over. But I like them on top of each other, and the reason is I work with 3 left-handed people, and having right-handed tongs or left-handed tongs, I just said screw it. I'm just making tongs that all my friends can use, and I don't have to go, you know, have different sets. So that's my spiel there. All right, we're drawing out the reins with the round back flatter. I think there's a nice little video, but okay, we'll go over the video first. All right, so you're just drawing it out with the hammer, doing a little bit of a hit turn action there. Again, back to the workshops. Ask your education folks to see if they can put something together. It would be well worth the energy. So here I roughed it out just underneath the flat dies. And here in a second, okay, here we go. I have the round back flatter, and I'm just going back, smoothing everything up with the round back flatter. It is your best friend. Even if you have just a regular flatter with a wooden handle, it's still your best friend when you guys are striking. It smooths everything out. It's just a wonderful, wonderful tool. And again, these are kind of at low heats. Almost get, you know, to a planishing heat. But you can get a lot done really quickly. I have been drilling my holes. I was going to ask if we're doing a cold. I would say cool. Yeah, cool. So I've been drilling my holes. I know some folks. I remember Frank Tercel told me if he has one pair of tongs he needs to build, he'll just punch it with a punch. But if he has a bunch, he'll just drill them. So I don't think there's any right or wrong way. I know that I can be very precise if I drill it. And with my insert tools, I don't know, I just drill them. Okay, Miss Victoria has raised her hand.
So when you're drilling, isn't the metal at that point hardened or harder? So it'll dull your drill bits out or not?
So what I do, that's a good question.
Especially if you're quenching.
So I don't quench. Let's say I make a pair of tongs. Like this set of pair of tongs is an insert pair, and it's 4140. And I will bring it up to a heat, you know, before I know I'm going to drill, and I'll put it in my vermiculite or whatever. And basically, I'll anneal it, or you could let it sit on the bench and just let them cool, nice and slow. Because I usually have them all, you know, I have piles lined up. So that's not an issue with me. I'm not. So then occasionally it seems like you'll get a hard spot. You could use a little pilot hole. But most of the time you can get through. So and even sometimes on the mild steel ones, there's some, who knows what it is. Was it like A36 is everything? So so if you're having trouble, maybe go back, stick it back in the forge, and try and nail it. See what that does. I mean, I was a machinist long time ago, so I'm really good at sharpening drill bits. Just part of the routine. So anyway, good question. All right, setting a rivet. Basically, sometimes you can set the rivet, you can just start it cold, get it set, and then you can go back and you can either use a torch or you stick it back in the forge and get a heat and start basically mushrooming it all the way down. And I think Zane is the one who had to set the rivet because my arm was shot when we were shooting. So let's move to the next slide and see if it's the video. Okay, yeah. So here we basically take it, and I think I heated the rivet up a little bit, but it lost. And we just went through, and I just kind of peened it over just to keep it there. And I think this is Zane coming back, actually making the rivet. It was very nice of him to help us. He had time for us for a moment. So What we did was we want an 1/8 inch spacer, so we just got a piece of 1/8 inch sheet, and we're using that between our jaws. Yes, it will get hot, so either just beware that that piece is going to transmit or transfer the heat into it, or maybe get a really long piece. But yeah, your spacer block will be hot, and we've all made that mistake. So it's nice to have your jaws or bits parallel. You don't want them all cocked off. You want them nice and true to the rest of the rest of the set of tongs. Okay, yeah, and you'll see in the next slide where you want the back, the very where the boss is, right there, right where Victoria's kind of pointing. Yes, you want that to be 1/8 inch all the way out to the very tip. And you can see in Asprey's photos how he's truing this up, basically setting the very back first and then moving over to the edge of the anvil and finishing off. So he has some nice slides. It's like he's professional or something. So now there's a little video of, I can't remember if Victoria was doing this or if Zane was doing this, but Victoria, she's left-handed. Yeah. All right. So we get to the basically the reins. Again, these need to fit you. You know, the length needs to fit you. These little guys, they don't need to be too long. They're gonna get in the way if they're real long. So, and they need to be comfortable. So that you need to have enough space where you don't feel like it's nice to have a little bit of spring action, but not where they close, where you have to sit there and mess with them. But, so make them to fit your hands. So let's move to the next slide. Okay, let me tell you what I did wrong here. Is I should have put it in the vise where the boss is. I just had it on the end of the bits here. I should have clamped it where, basically where the rivet is. Because when I bend these apart, you can see that move a little bit. So a little word. And a torch is really handy too. I love using a torch. Getting the isolated heats, they're quite handy. All right. I like to, when I'll heat my boss up, and this rivet is probably nice and tight. And I like to go back and forth until I got a nice free moving set of tongs. Especially if you're using a higher carbon, mid carbon steel, just keep working them. Some folks, they'll take, if it's mild steel, they'll heat them up and they'll put them in a bucket of water, and they'll move them back and forth in a bucket of water, basically quenching them. I tend to avoid that, but I've done it. I just keep moving them back and forth, and Aaron Simmons taught me that, and that seems to be my favorite trick. I like them to move nice and freely. So yeah. All right. So when you're working on this stuff, do you know how many pairs of crappy tongs I have behind my forge? Lots. So again, that's where you put this in. Focus on progress, not perfection. I mean, just you will eat yourself alive if you're trying to make your first pair of tongs the perfect. My first pair of tongs, I moved over to my barbecue. So, and keep them. Keep the early stuff, and you can see how you grow. Work on progress, not necessarily trying to make it so perfect. So, I think we are done. I'd like to share a little bit of top tool stuff with you guys. So here is that round back flatter that I just welded on here. And here's another one that has a little ridge. And I'll show you how I made that. You can see that. So basically just and actually Toby Hickman, we made this particular one in that workshop. And that's how I made this round back flatter.
Dennis, did you preform that bar before you stick it in there at all, or just stick it in there as a rectangle?
No, you stick it in as a rectangle.
Okay, and just smash it in.
Yeah. Let me show you another way of using a flat die. This is called a side set. And you can see, I did this morning. You can see I kind of took this side set in. Basically, this could be a pair of tongs. Basically, I flip it around. This could be your boss, and that could be your reins. You could come in with a little set tool, wham, 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 and you would have this material out here, and you could make whatever, you could make a scrolling tong out of this sucker. So, there's a lot of cool stuff that you can use with top tools. What else would you guys like to see? See if I can show you. Here's some of my tools, everyday tools. Just side set. I use a lot of ball punches. Here's another side set. I mean, side sets are just awesome.
You need two side sets to make one set, right?
On Toby's, here is he has it angled one way. Or it actually is the same way, but when you turn it around, you get the other here's this one. I turn it around and I do this one. So you can see that they're like that. So quick and handy to have them off of the same tool. Super cool. Super cool. I mean, you do that in one operation. Bang, bang. So, anyway, any questions? I have not been following the chat, but chime in.
Yeah, everybody just let yourself back into the room and
Yeah.
What did you use for the bottom tool to make the bottom tool of the ridge for the ridge rounded back platter?
Well, let me back up here. So on the round back flatter, you have basically a big, well, it was like a 2-inch diameter fuller, and then probably a 1/2 inch fuller down the middle. How come I can't find my here?
So 2 separate fullers,
Yes,
one
were,
and then the second one. Huh.
Yes, exactly. Yeah, and I should have. Yeah, I wish I would have brought the 2 fullers. This was one fuller, and then this 1/2 inch fuller to make that trough. So, and you can make them any size you want. I mean, it's you can make a ginormous one, but most of the things you don't need them really big. I could see working for Michael Bondi, you'd need some big ginormous thing, but I mean, doing reins on the tongs, everything I have is just perfect. So, let me show you this while we're thinking of it. If you guys can see that, that's how that was made. That side set was made just like this. So,
Oh, okay.
What thickness material do you generally start with? For that?
It's been too many years. I would have to experiment or kind of go back to the drawing board on what it takes. For some reason, I'm saying 1-inch square, but I
mean for the bottom tools.
the bottom
tool.
that looks like probably 1x4, something like that. So I could measure it out and throw it on the Facebook page, if that would be helpful.
Yeah, I'm just looking into starting to make some bottom and top tooling, swage tooling for power hammers. So
Right.
Trying to get an idea of what thickness you want to do for your dies.
Well, you can always message me too, and I'll take a little photo and with my ruler and stuff like that. I'm always open for that. So anyway, so there's so much to learn with power hammer, power hammers and power hammer tooling. I mean, I think it would be phenomenal to get Mark Krause out here to go up and down California. I think that would be phenomenal to have and have him teach the same course. Would be awesome. And I guess he could stop in Colorado too, Victoria. or you might have to fly to California, and Mike might have to drive down. So, anyway, let's keep going. What any other questions that kind of come to mind? Okay, Mike has raised his hand. Go ahead, Mike.
Trying to get to the unmute button.
Nice here.
So much a question, but I wanted to make a couple of comments about scrolling tongs. For me, anyway, the things having gone through a few pair, I tend to put a little bit beefier boss and reins both on my scrolling tongs because it's the one set of tongs that I'll be reefing on twisting.
All right.
Other tongs, I'm never really, maybe some short-handled, flat-jawed ones, I'll make some beefy reins because I might use it for bending something. But my scrolling tongs, I'm constantly reefing those things, twisting on them. So I tend to make them short and
fat.
Yeah.
Fat. Yeah. Okay.
And then the other thing about tongs in general, I'd throw out, and I don't know what kind of where everybody on here is at in their blacksmithing career or something, but I tend to have periods, even longish periods away. In fact, right now I haven't lit my forge for like 6 months. And one of the first things I like to make when I come back to it is a pair of tongs because it's something that's useful to me. And it has most of the fundamental moves of blacksmithing in it, right? I mean, it's got, and depending on what kind of tong you're making, you can have upsetting. You've got setting down, you've got tapers, you've got forging, you've got punching, you got bending, and you're kind of running out. If you do drop the tong weld, you've got a forge weld on there.
Right.
So you run yourself through damn near all of the fundamentals of this craft in making a pair of tongs. And so I actually, I'm not bored if I'm making a set of tongs. My tongs are nowhere near as beautiful as Dennis's though. So I cherish the couple of pairs of his I have. But anyway, I just throwing that out that some people might look at a lot tongs is too basic or something, but it's really not.
Oh, no, you're right. So a lot of the size, let me go back to the size part, is supporting like the number 2 and number 3 scrolls that go into those grills. And that's so that's kind of what that's a great place to start with. And then once you get into bigger John Barron scrolls, we'll make the tool accordingly. Yeah. So that's awesome. Yeah. Good input.
I have a pair that are the size of needle nose pliers, and then I have my big lumpy pair.
Right. Excellent. And you have your ones that are, the reins have hearts on them. It's too bad you didn't bring those. So actually, as a joke, I made him a pair of knife tongs because Mike is a bladesmith, and as a joke, I made him like super, super long, and at the end they curled up and made a big, big heart. And so
nice.
Good one. It's nice to be able to have friends that you can joke around with, and they appreciate, the love you put into a set of tools, and especially if you put a big, big heart on it. So, but yeah, Mike and I have been through a lot. So good stuff. Any other questions or stories or comments or?
Yeah, Jake's has his hand up.
Oh, okay. Go ahead, Jake.
All right, so I think I'm unmuted. I just had to share my first pair of tongs was back when I took classes with Art Adams down in Fresno. They were scrolling tongs. And I have them right here.
Oh, cool.
They're just about a 1/2 inch square mild.
Okay.
But they still work pretty good.
Yeah.
A little frozen up. I mean, they're more like needle nose. A little bit out of center when I tweaked on them a bit hard one day, but like I said, keep your first pair of tongs, and I would always have these on my rack.
That's awesome.
A little bit rounded off, but they work.
Yeah,
I
right.
cherish them.
That's awesome. I like it. I like it. The progress is pretty cool. That's part of the game. A lot of this is the journey. We learn so much on this journey we call blacksmithing. Torture it may be sometimes, but I certainly have learned a lot. Any other stories or
Do you use the same die, like the power hammer die you showed us, for all of your tongs? Or do you make different ones for different types of tongs?
I do have, here's a this is a set of flat jaws, and I have a pair of combo dies. And the combo dies, well, half round, half flat. They're awesome for just drawing material out. So fast, so nice. And if I'm doing farrier pairs, I tend to use the round or the combo dies instead of just the flat dies. So, okay, so what's the key thing about forging titanium? Okay, it has to be hot, it has to stay hot, and once it cools down, it just stops, and you just like, your body aches because it just stopped. It's pretty cool stuff. I can put, yes, it has to be the right alloy. I have that number somewhere on my phone. I could put it maybe on the CBA page for everybody. If and I've seen the stuff on like eBay. I haven't bought. I was given some a long time ago. I actually made some scrolling tongs for Monica Coyne out of titanium because she was traveling to John Campbell's school. So this stuff is a booger. Don't start with that though. By God, don't start with that. Just stay with mild. So, but I'll find the alloy and I'll put it out. Because I think some stuff just cracks. And I bet you there's some farriers. I bet you if we put it on the Facebook page, some of the farriers will chime in and
Whoops. Hopefully he'll come back.
No, Dennis.
I don't know. We're about at time. I really want to thank everybody come back, Dennis. Come back. No, I want to thank everyone for being here, and we're always available by email if you have any other questions that come up. And hopefully, if Dennis got kicked out, he's making his way back into the room. But I liked the show and tell for sure. Yeah, maybe he's coming back. Are you back? Oh, nice. There's the heart. Tom.
Nice.
That's nice, Mike.
Very nice.
Beatrice, I'm glad you liked the cheat sheets. I thought at least give you the relevant information. Okay, good. And Jim, you are welcome. Will this presentation be available to view again? So I'm gonna, it takes like a day for the Zoom to process it. I'll download it and chop it up into reasonable chunks, and then I'll send you guys all a link to those. They'll be in the Google Drive, the CBA's Google Drive.
Thank you.
You're welcome. Okay, I'm glad you guys liked it. Awesome. Excellent.
Did Victoria Patty have a story?
No
She says
stories?
no.
Dennis wants me to tell you guys about the story of we were a team in a competition down in Florida, and the competition was to forge. I forget what it was. It started out as maybe
1 inch. Yes, 4 inches.
1 inch by
bar.
4 inches, and you're supposed to hammer it down into a square. Any square, any size square, but as soon as you get to a square, that the competition is over. And we came in like dead last because he picked out these pair of scrolling tongs for me to hold on to the parent stock with. I'm like, I'm not using these. And he goes, "You'll be fine. These will be good. These are good." Yeah. Yeah.
Thank
Good old
you.
scrolling tongs.
Yeah.
Nope.
Yeah, see that had to be told. That had to be told.
It was so appropriate for the topic. And how not to use scrolling tongs.
Yes. Don't use them to pick up and hold things.
So I wanted to share. I take classes with Beth, and in her class we made that swage, excuse me, that Victoria showed for making the scrolling fork without doing a weld. So you just bend one piece of metal.
Ooh, that's slick. Nice job, Beth.
Yeah, low tech. Get through the tooling. Get onto your work.
Very
Nice.
clever.
Yeah.
Tooling is the key.
Thanks, Bo. That was the perfect thing to share. I like that. I hadn't seen anything like that before.
Awesome.
There's no MIG welder in the barn.
Nope.
Nope.
So, well, thanks for having us on. Enjoyed squawking.
Yep. And Beth's going to keep going with the level 2 skills. She's got the C's and S's and the collars coming up. So I think they're filling up fast. And big thanks to Beth actually for taking on all these level 2 skills and getting us all in line. She's the boss tonight.
Victoria makes everything happen. Thank you, Dennis. Earned that.
No, that's awesome. No,
Yeah.
it takes a village, so might as well just state California. I mean, we're moving so well, so good, made so much progress, especially this last year. From, well, I hate to say it because we're locked down. What a great opportunity to do this. So why not?
Well, and what Dennis isn't saying is this whole let's do something on Zoom started with him when he got Victoria Patty, Linda Metcalf, and Ellen Durkin to talk to us about design, which that was a great set of shows. And some of them are on YouTube if you didn't catch them the first go round. So yeah, I think you kicked off a whole new era, and I hope we keep going.
Yep.
Cheers.
Yep.
And it wouldn't happen at all without all of you guys participating. So really appreciate it. And I love seeing all the same faces. It's good to see you all.
Awesome.
Bo's always here. Carol, Beatrice, Chris. Yeah.
Webinar club.
Yeah. Williams joined the party. Yep. We got
So, any questions come up, just throw me a message on Messenger and I'll give you dimensions of whatever I have. So please, I'm here. Victoria's there. So, and you can always bug Mike Lim too. He's always available.
Yeah. Right. I was on video chats for 8 hours today.
oh geez.
Well, 10 now.
But this is the good one, right?
This is the good
Oh,
one.
yeah.
You got to do some show and tell.
Yeah. Well,
You all.
I know Mike has a few stories too, but that'll be maybe another time.
The invite said, "Be nice to the instructors."
Oh, okay.
Good job reading. Yay.
They're coming after me. I gotta go.
Hey,
All
bye,
right.
Carol.
See you next
Bye-bye.
week, Carol.
Bye,
Bye-bye.
Carol.
See y'all. See Anna. See Bo.
Okay. Bye.
See Beatrice.
Okay, bye.
Bye,
See ya.
Bo. Good to see you.
Yeah, good
Thanks,
to see you
Mike.
too. Hello.
See you guys.
All right.
I like us, Victoria. I like us both on here, and they can really see there's two of us
That's
Yeah.
Yeah.
with our short blonde hair.
I'm gonna
Take
wear
care,
a
you
wig.
guys. It was great.
Oh, bye, William. So good to see you. Anna,
Awesome.
always good to see
Thanks
you
for coming.
too.
Hopefully see some of you in person soon, August. I'm taking over the organization of the Hammering Roaring Camp.
Oh, we should have had you do a little
Oh.
advertisement.
I
Oh,
forgot, yeah. For the next one.
We'll get you in the next round.
yeah.
But you're going forth, right? Like you.
Yep, we are going forth. We're gonna, we're doing really well here in Santa Cruz. And Roaring Camp has been open since January, doing like socially distant rides and stuff. So currently we are going forward with it.
Yeah, I've got it on my calendar. August, what is it, 21st?
I think it's 20th to 22nd. Yeah.
That's good news.
Yeah, it's really good
Yeah.
news.
Yeah.
I've decided we're going to do a like a little mask making competition. So mask / PPE, metal making competition.
Right.
Oh,
Awesome.
nice.
That's a good
Okay,
event.
good.
Yeah, I had a really good time last year with the Open It with Art competition. I thought maybe
Yeah,
we'll do
since you
something
won.
similar that's a little, thematic.
Right. Right.
Love it.
Well, so
Okay.
so they're serving food there too. So everything's back.
Everything's back. Right now, just as far as Roaring Camp operation, serving food, they have areas that are marked off for eating, maskless areas, but the rest of it you have to, wear a mask in.
You have to wear a mask. Okay.
And then
Yeah.
they stagger people on the train, parties on the train.
Right. Right.
We'll see where we're at in August.
Yeah,
Right.
might be over.
Might be over. Yeah. Depending on how many vaccinated members come.
Sure.
Um,
Right.
So,
I hope so. I mean, it'd be really nice to get back to hugs and kisses and whatnot with your friends. It's